So welcome to Visual Components webinar. This is second webinar this year, but the first one about OLP. So happy to have you here. And of course, happy to have here Vanessa Loiola. So Vanessa is robotics voice on LinkedIn. You probably know her from the posts, but also she's the founder behind the Valoy automation and robot programming specialist. Hi, Vanessa.
Hello, everyone. Welcome to this first webinar here.
Yes, and my name is Ekaterina Berdasheva. So I am a marketing specialist here at Visual Components and responsible for webinars and trade shows. So you might have seen me at the shows. And then our second speaker, Severi Keisala. So Severi is application engineer here at Visual Components in OLP team. Hi, Severi.
Hello, and hello to everyone also joining this webinar. Happy to see you here.
Then I give my floor first to Vanessa. So Vanessa will have some layout to build with you. Go ahead, Vanessa. You're muted still, I think.
I'm just going to share my screen.
Yeah.
Are you seeing my screen now? Yeah.
Yes.
Okay. So guys, we're gonna see how easy to set up a robot cell in just a few minutes. But if you have, or when you download the software, or if you already have, you probably notice there are a few options here. The layouts OLP on home, on the eCatalog, there are a few options there already of some robotic cells, so you can like drag and drop. But today I'm gonna show you how easy it is to build your own robotic cell. Okay, we're gonna choose. We chose to show a welding robotic cell. So keep that in mind here. If you have any questions, you can write that down on the Q&A session, and then we're gonna answer in the end. Okay. So first thing we have to choose is the robot. There are a few options here. Well, I would say there are more than just a few. For this application, I'm gonna choose FANUC, and I'm gonna choose the ArcMate 120 ID. Okay. So we just drag and drop the robot, and then you're gonna just zoom in. So that's my robot right here. And now I need a tool for my robot again. So we can just go here, robot tool. There are a few options, and I'm gonna choose Visual Components, and I'm gonna pick the one for the welding gun hollow arm. And why that? Well, first of all, our robot, if you haven't seen this robot in real life, it does have a hollow arm for the cables, okay? So that's the reason that we have our hollow gun welded. And that's, I would say, one of the things I like most, because Visual Components, because you can just drag and drop the part to the robot, and then you will attach for you. So if you see here, you're gonna get close to the flange, you're gonna see a green arrow. So that means you can just get close, and then that would attach to your robot. If that doesn't show in your application, just double check on your menu tab here that PNP, that means plug and play, is selected. So then you'll be able to connect both. That's our first step. Second step here, we want to that tool face down, so you can rotate yourself, or like the way I prefer, because I like to be precise, you can just type 90 degrees, or sorry, 180 degrees, and that would face down. Okay. The next step now, we need a position for our robot. So just above here, you're gonna see robot positioner, also in the eCatalog. And I'm gonna choose, there are, as you can see, a lot of options. So I'm going to go to Visual Components, and then I'm going to choose the robot floor track. Again, just drag and drop. That's how easy it is, how simple. Then you can use your mouse to move around the robot to visualize better. And here again, you click on your robot, and you're going to use the PNP application, plug and play, to place our robot on the positioner. Again, if you notice, there is a green arrow there. So just drop there, easy, simple. And from here, you also can turn your robot to face where is going to be your workpiece. So for our workpiece, it's going to face this way. Again, you can turn manually, but I like to be precise. So I'm going to type 90 degrees, so I know it's going to be exactly on the position I want. For now, we need also a position for our workpiece so we can move together. So we close here, just going to close, and then we go to robot workpiece positioner. Everything's simple there. Again, few options. We go to Visual Components, and then I'm going to choose the positioner to access. Drag and drop, and that it is. Again, you can turn manually, or you can type in how much you want to turn. And also, you can place that relative to the robot positioner, because the robot positions, it's a linear, so it's going to go in two directions there. So you can place close or not, depends what you want. For this application, we're going to place more or less here in the middle of the positioner of the robot positioner. Don't worry, we can change that later if it doesn't work. If the robot doesn't reach the positions, we can move the workpiece positioner later. Okay, we have that done. Then we need to connect our robot to the workpiece so it to be able to move together. So again, simple. We go to Program, Interface, and then you can just click here on Robot Interface. So you see this line, so that means now they are both connected. Then we close. So if I move, let's see, joint there, move, and move all them tracked. So as you can see here in jog, we can move all of them, including the robot, one by one. And if you want to go back to the main position or home position, as we call, you just press this button here, and the robot will go back to the main position. Now, what we need is a workpiece, because we do have the robot, the tool, and the positioner. So we need a piece for our robot to weld. Simple again, we're going to go products and containers. There are a few options here. Well, I'll say more than a few again. I'm going to choose this one for this application, the subassembly. Easy, just drag and drop. And again, when you're getting close where you want to drop, you're going to see the green arrow. Okay, when you see that, that means the PNP are selected and you can drop your part. And now, so you can turn or not that workpiece. For this application, I will not turn. So that is going to be where I want my positioner. And for now, before we start our program, the welding, we need to adjust a few things in our robot. Because we just attached the tool, but we haven't select, I would say, the two center point of our tool. We need to define that first. So here on the program tab, you select the tool number one. There are 16 options here for the FANUC. Let's just select the number one here for this application. I'm going to rename it. So I would say good practice, just name something that makes sense for you. For me, it makes sense torch because it's the torch. But again, name it something that makes sense because you're going to use that later. And now, as you can see, trying to zoom in here, my tool center point is based on the flange, not on the tip of my wire. That's where it should be and where I want that to be. So I'm going to zoom in here to change that. That's my wire right there. I'm going to select snap, and then I'm going to click on the center of the tip of the wire. So now my tool center point is not based on the flange anymore. It's based on the tip of the wire. So that's how easy to change that for you. So when you select from word to object, now you can see it's facing that way. But for visual component simulation, we need to do something else here for the coordinate systems. As you know, every robot has a different coordinate system for the tool. But to work on the simulation visual components, the X and Y need to face the other way around. So I'm going to turn that 180. So now I do have my X is facing the robot, and then Y is facing that way. And then Z is still the same position. Okay, this is just for the default application of visual components. For the simulation, needs to be this way. Okay, otherwise it would crash. Like you would see a difference on your program. Now we need to set up our base. So we do have our robot. Now I'm going to jog. We have the tool. Now I need to select the base. Again, you have a few options, but I will keep the first one. Configurations, we're going to name it that. Again, guys, name it something that makes sense for you. This is our base, and then the node here, what I want the robot to sync with. In this case, in this application, I want to be the base of my workpiece positioner. No. Here. So select there. So again, you're going to just see this square here with the arrow. So you're going to click there, and then you're going to see the red box around the parts. What you want is this here is the positioner, the base of the positioner. So then our robot would sync with that. So when you go back to jog, and then you move your robot, you move around here. Now I'm tilting positioner. The robot is moving together. See, now they are in sync. Go back to the main position. Okay. The other thing, if you're using welding before or not, your tool, your torch should be facing down, not straight like our one here. So we need to adjust that too. So let's type 90. Again, you can turn manually, but I do prefer turn be more precise. So you just type -90 on the joint number 5. That's the joint right here. If you turn there, that's joint number 5. Back. So -90. That's done. So let's say this I was home position. So if the robot to start the program, I'm going to start like this, or if something I move the robot to a wrong position and I want to go back to our save position or home position, you can save this. So now you just open here in configuration and then save state. So now that's our save state. So if I move my robot around the positioner like this, and then I just want to bring it back, you just reset it, and then that's your home position. Okay, so we have that set up. Now we need to activate our collision detector. Sorry, the collision detection. So it would not crash, or at least would tell us if it's going to crash or not. So we go to edit detector plus other one is. So add the collision detector. Then you're gonna see side A and side B. For now, I would say it's very simple. Why you want to select the robot to not collide, and also the tool, that should be our A. But you do need the wire to touch the part. So you just open here when you can see plus and unselect the wire, because the wire needs to touch the part to weld. Then on the other side, side B, we need the workpiece and the workpiece positioner. So green is everything, green is A, and everything in blue is B. That's simple. That's all we have to do for here. You close that. Then we go to settings, and then we need to set up our path. So we need to set up robot collision detector, part we just did. And then we're going to select the tree first, via process and search. And then we're going to hit apply. So now we're setting the parameters so the robot would not collide to the part, and at least would show in yellow if it does. Okay, so for now, our robot is ready to create a program. Our robotic cell is ready. So now how you weld this part. So we just zoom in to make life easier for everybody. And then it's, I would say, very, very easy. As you can see, you have a few buttons here on the bottom of your screen. We're going to choose the second one, that is create path. Select that there. And then you got to see, like I'm not selecting yet, but like if you can go around the part, it's showing for you how would be the path around that corner or this corner. I'm going to select the top one here. The good thing is showing like everything in yellow means that is a linear move, and everything orange is a joint move. If you don't know the difference, I made a few posts a few weeks ago explaining what it is, but that's how the path is defined. But also you can change the parameters for the welding. So you have a few options here. I'm going to ask later to Severi to explain to you what it is. And then if we press play, the robot will go to that position. Okay, I'm going to just speed up a little more here. But before you tell me I'm wrong, I already know. You shouldn't weld in this position. The face should be down, otherwise you weld will be wrong. Okay, so that should not be the way you weld, but I would like to show you first. So when you click here on that line, that position, you can go to auxiliary and then go to PAB. And then this will turn, that will shift the positioner for you. So now it's facing down. That should be the correct way to weld. And then I'm going to just ask Severi here to give a more deep explanation and why you can use that, or why you should use that.
Yeah, so of course, when we talk about welding, we are depositing liquid metal over there to the workpiece, which means that it will go down in the gravity direction, especially now in this case. We also have the lines that you explained over there, the yellow ones and the orange ones. Actually, the yellow ones are linear motion, the orange ones are circular motion. So the software is able to automatically detect the circular motions throughout the path. And together now with the auxiliary axis options, we are able to automatically calculate the optimal welding angle for the workpiece positioner throughout the entire weld. So by selecting the BA and PB positions with the icon there on the bottom side of this screen, you are able to automatically define so that your path will always be in the wire down position. So it will also turn automatically and synchronously throughout these circular motion points and any point where the path of the weld will diverge. So you can see that motion now when you are running the program. And the nice thing is that this program is also post-processed correctly to the actual robot. So the software takes care of the optimal welding angle for you.
Yeah, that's fantastic. Thank you very much. Another point that I explained before, like for some reason, you place in the wrong, or you need to change a little bit, shift, or for some reason you can shift, and the program will, you don't need to do anything on the program. It would it would update itself. So if you can move around the parts, the positioner, or even the robot there, it would see that you would adapt the path on its own. So that's how simple it is. And also you're going to see here at the bottom, like messages. For this one, we can check the enables here. And then if you press play, see if you're going to reach. Forgot to enable the enable detectors to see if you're going to crash. Doesn't see anything, at least everything fine. But let me simulate the crash here. Work extra. Let's check the path to see. So if I check my path, okay, showing possible collision in the end here. So joint limits. So that explained to you, showing to us that position is, as you can see, my robot's really facing down. So it's important to check that, like your robot might not reach or is really on the limit. So we need to move our position a little bit that way. And then we check again. So now is everything green. So that's all. That's how simple, and we just did that in less than 30 minutes. I created easy simulation to how to weld a part. Let's try to have any questions there. No. Want to start the do we have any questions?
Yes, checking the Q&A section. So far, we don't have any. So
okay, so
maybe
I don't know if it's good or bad. Like, did I explain well? If I didn't understand it all.
very clear explanations, maybe. Yes, so I think that maybe we can have some of them later also, but then maybe Severi can continue with his part of the presentation meanwhile. But please feel free to ask anything. No stupid questions in this webinar.
Yeah, we are here to help. Like, I don't think I showed that very explained because it was less than 30 minutes. But guys, that's the moment. Like, you have any other question about the software, feel free.
I think we actually have one now. So Aaron Kumar is asking, can we change the velocity of the robot?
Yeah, so on that topic, of course, we can change the velocity. So what will happen in the robot program is that we will have the motion statements that are built inside the path statement that we have created. They have speeds that we have set specifically for welding, and then approach and departure air motions. So those come from the default values that we can set inside the software, and we can change those either with individual points or use these kind of like speed templates that we have saved as defaults in the software. So you can do that. Then to monitor the actual joint speeds, if the question is about joint speeds, we can set the maximum speeds for the robot component that we usually take from the robot data sheets that they match with the robots on the real factories. And then we can monitor those joint values also there in the simulation.
Thank you for your answer. Then I have one hand raised. Let's see if it's possible to unmute. Yes, please try to speak up. YEPUB, I think is the screen name.
Hello.
Hello, hello.
Go ahead.
So is it possible to like create a cycle time in this?
Yes. So when we complete a robot program where we have, for example, set a specific process for the robot, we can run through the simulation and we can get an estimate out of the cycle time. So the Visual Components simulation runs on a generic robot controller. So the basic level version of the software only contains the general robot controller. So you can have simplified versions of the motion simulations, which might not 100% match with your specific robot brands, because there are differences in how different robot brands are executing the motion through their robot controllers. However, it is possible to connect Visual Components to a robot controller directly or to a virtual robot controller. This is, for example, possible for KUKA, FANUC, and ABB, and many others. You can find details from our website for that. But through those controllers and virtual controllers, we are able to do accurate cycle time simulation and estimation.
Okay, thanks a lot.
Oh yeah, can you export the source? Yeah, I'm gonna show you right now. Good question. So yeah, you can select export here. Yes. You can download for FANUC. FANUC here, download. I'm gonna go to desktop and just now. Then if I opened my folder, yeah, the webinar now it's saved, so you can see, and then you can see the positions there, and also you can change the speed here also. When you can change that on your robot, but then you can see here the positions, all the configurations, because that's how you're going to transfer it to the robot.
And one more addition to this is that our post processors for all of these different robot brands are written in Python, and the Python writer files that are provided together with the software are open. So anyone can modify in the end the output code. By default, we have different options for different controller generations and configurations, and those are usually set during the commissioning process of this software together with our expert team. But if you want and you're capable in Python programming, you're able to customize all those syntaxes also yourself.
Thank you for very good questions and answers. I will take more from the chat. I think we missed one from Vitaly. So Vitaly is asking, I would like to rotate the weld gun 90 degrees clockwise, so robot has better weld kinematic position. Can we try that?
So you want it to turn the question. How the question again? So you want?
We want to rotate the weld gun 90 degrees clockwise, so robot has better weld kinematic position.
Okay, the tool itself. 90 or 180? Like this?
It says 90, yeah.
Like this? It says 90. Okay. From 90 degrees, it's going to look like this. Is that what you meant? Is that what he meant by 90?
Let me see if I can bring Vitaly on
Mhm.
screen. Just a second. Then he can open the mic. Vitaly, please try to ask.
Hello, everybody. Can you hear me?
Yes.
Yes, sure.
Hey, Vanessa, Katerina, Severi. Nice to hear you and see you. Thank you for the demonstration. Very informative and impressive. I just meant, you have the robot almost folded down altogether with, at least in Yaskawa world, it's U and L, second and third axis. So to have it like in a better kinematic position, you can approach the weld not in like X direction, so to say, but just rotate it 90 degrees, either plus or minus. So to approach with a torch from the side,
Like this.
if you understand what I mean. Yeah, kind of like this from the side, and then
It was like this. So
yeah, it was like this, and then to make it just like with the TCP pointing to the part, and yeah, something like this.
Okay, let's save this port and we can try again.
Yeah, and then somehow to apply it for the whole weld.
Yeah, so now, well, now it's crashing. In this case, it would crash. It did crash. Destroy, wait.
But you
It
got
did
the point.
crash.
Yeah, it's not like this. It's. Can you move? Can you go to the part now? Just to any point of your weld.
Yeah,
Yeah,
there.
like this, and then if you will rotate 90 degrees counterclockwise.
Thinking I need to approach maybe the other way around.
Yeah. Because I'm just wondering, do you need like to then reapply every separate point, or is there any like button to apply a certain torch position for the whole weld? Or
That would do.
Yeah, now,
That's good.
Vanessa, can you activate
That's
the weld
not what we
statement?
maybe Severi, you can jump in and
Yeah, you don't get if that's what he meant, or just for that position.
Yeah, so if you want to do changes that you want to apply for the entire weld, you can do that, for example, in the adjust options. So in the adjust of the weld, you are able to set the wire angle. So if you, Vanessa, go to the adjust tab of the path setup there, so there the first parameter allows you to rotate the tool around the wire during the path, and those changes will affect the entire path. So exactly that one. But now what we can do is first, if you can reset the simulation from the simulation setting, so we can go back to the initial state so that simulation is not running there in the background. Then we can activate the statement again there from the left. So click on the W1 on the program editor. There. And now you can select any of the adjust parameter options there on the right where we change the wire roll. So that wire roll option will then affect all of the points in the path when we do those changes. So in the adjust tab on the angle where you can see the -90, any change that you do in that value in that box will automatically affect the entire path, and those will automatically change also all of the motion points accordingly, depending on how is the change done and applied. In this case, what I noticed is that when we reoriented the tool, now our TCP is still following in the old orientation. So this is why the simulation can seem to be a little bit off. So if we go back to the TCP options where we set the TCP, now the TCP is probably pointing still in the old direction. So we need to refresh the TCP to the new welding gun position to make it feasible for the robot.
Okay, gotcha. So now we need to 90. That would be that would be the direction, correct?
I think it's not now exactly pointing in the correct direction, so you can just use the snap option again to snap it at the tip of the wire and rotate it so that it follows the correct orientation.
Yeah. 1 second.
Severi, while we are doing that, I remember then we can also make this weld points table to pop up and then like manually fix the orientation of the torch for one point and then apply the orientation for all the points. Is it maybe the preferred way, or it's better to do it with TCP change?
It depends on the application, of course. Like in this stage, or what we are now doing, it's basically we are doing kind of like a layout concept study. So we don't have anything exact there on the real shop floor, so to say. So if we would have something that is already established, probably it would be then easier to change the points on the path because our tool and robot have already been set up correctly. But now when we are able to modify the setup, we don't have to rely on the hardware there on the factory. We can basically do it the simple way by just changing the tools and changing the configuration and so on.
Okay, so you can play with TCP as much as you can here, of course.
Yeah. So now we're seeing that it should be a little bit better again.
No, it's
and now,
yeah.
This is exactly what I was talking about. So this kinematic.
Yeah, no, because I just turned the tool, but I forgot the TCP. No, yeah, that's the point there.
Thank you very much.
Yeah, thanks. Now it's okay. So we can change the TCP rotation in this default layouting. So I learned something new for me as well today. Thanks.
Thank you.
Thank you for the good question, Vitaly.
Then I have some questions that Severi already managed to answer in the chat, so I'm just going to read out. Does this software have Stäubli robot simulation? Yes, we can simulate and post-process programs for Stäubli robots. Then next question again from Arun Kumar. Can we import any CAD model to the work environment, or is it only limited to the library components?
Yes, so this is a good question because, of course, now we have been working with these pre-modeled and pre-set up components from the eCatalog. These are easy to start with and they work very well for conceptual studies and like building the initial configuration of your robot layout. But to work with your actual parts, you, of course, need to import those to the simulation. And those we can import in the simulation by using the CAD import options. So in those CAD import options, we are able to import the geometries and models into the software, and we can then work on those, either build a model out of those, or then create a welding program or a robot program to those workpieces. So that is possible. You can find the information on what CAD formats we support in our website, and I guess those are kind of like the most common ones, existing ones up there. Should be quite easy to do and test out yourself also in your trial period.
Yes, and thank you, Christer Eriksson. Our Swedish colleague is sharing the link in the answer in the chat. Thank you, Christer, for helping out, and thank you, Arun Kumar, for the question, and Severi for answering. Let's move forward. So the next question is from Rick. How precise can you calculate the cycle time with your simplified robot controller?
This is a quite specific question, and it depends quite a lot of the case in question. So depending on the velocities, speeds, and accelerations, it can be precise, but there are also other things that take into account on how the cycle time is actually calculated, also taking into account inertia information and tool payloads and center of gravities and so on. So with simplified setups, we can get into quite accurate cycle times, but when we add more complexity and more kind of like details into what should be simulated with regards of like gravity and dynamic load and so on, then it can be a little bit less accurate. But if we talk about welding programs in specific, we can get to quite high possible accuracies because of the slow welding speeds. So usually welding speeds are quite slow when we are, for example, comparing that to handling applications and so, where the motion speeds are usually much higher.
Thank you again for the question. Then next is coming from Ismail. Please, how do you get the software? So is this about the trial license? Then yes. So I can take that. So if you missed in the beginning, I explained that at the end of the session there will be a poll, like a pop-up poll here in the chat, that everybody can fill out and receive a trial license in return. So please stick around for that. Then next one from Hugan Rush. This OLP, can we access all type of company robots? The answer is yes.
The answer is yes, short and sweet. So we have the eCatalog where we can simulate, if I remember correctly, it is over 1,000 different robot models. And we have the post processors for more than 15 robot brands with plus 40 controller generation versions. So you can simulate over 1,000 different robots, but you can also post process for 15 plus robot brands that we support.
Thank you. Next one from Mohit. Can I ask something about ABB robots? I have a MultiMove ABB robot 2400 IRC5 controller for waterjet application. I have added cut on off command instruction MC1 motion control. And now I need to link it with the output so that I can give it the cutting instruction without using the cutting power pack. Is it possible? Kind of a long question. Severi, can you see it in the chat?
Yes, I can see it in the chat. And this is a quite specific question for a specific application. In short, if I want to dissect this, we can use MultiMove for ABB robots, which just means that we can use coordinated motion between different ABB robots so that they are fully synchronized within the same program. This is possible, and the cut on and off commands with the specific instructions are something that we would probably need to take a closer look at on the specific application. How does the syntax actually work in Rapid? How does the program file structure and how all of that need to be set up so that the cutting can be successful? You mentioned the cutting power pack that is probably coming from the ABB Robot Studio world. So in our software, we don't need to separately activate any different modules for specific applications. We can work with different processes and different applications together in the same software without the need to activate anything else. So you can basically do welding programming or cutting programming, painting or deburring or surface sanding or something like that. All of those programmings within the same software, within the same license.
Thank you very much. Quite deep questions here. I think these are not beginner level, so we're keeping Severi busy. Thank you. Keep them coming. Next one, is there support for laser seam tracking and laser seam finding? Can the seam finding points added automatically?
So this is another good specific question, and of course the answer as always is yes. So there is support for laser tracking and laser seam finding. The differences are here that what type of finding and tracking are actually used. So are we using a sensor to fully track, for example, as we go with welding? What is the sensor type? Is like an active laser or is it inactive finding laser? What is the provider of the laser? What is the robot brand that is used together with those lasers? And how does the syntax then look and how is the correction done? Is it absolute or is it relative motion correction? And so on. So there are a lot of different options out there, but we are supporting many of the robot brands with these seam tracking and seam finding options. And these seam finding points can be added automatically into the software. So our software can do a feature so-called auto search that will automatically create searching points for selected weld paths, for example. And in those, we can set the automatic set of laser settings. So what type of groove parameters do we need to use, depending on what type of laser are we use for the sensing. So for example, servo robot lasers and such, Moto eyes for Yaskawa suites, those work very well with our software.
Thank you for the question again. Then the next question, I can see already our Director of Sales, Jarkko Siltamäki, has answered, but we will still take it here aloud as well. What should be the voltage and amp standard calculation in welding so that porosity can be reduced, and what is the perfect welding angle? Would you like to add, Severi, or shall I just read out Jarkko's reply?
Yeah, I can read on that. So as Jarkko has mentioned, it depends quite a lot on the scenario. So if you think about voltages and amperes, you only have kind of like a subset of what you want to initially use to get kind of like the ideal weld laid down with the materials that you have selected for your workpiece, of course. But in real life, you have a lot of other things. You also need to care about the welding speed, the welding position, as Jarkko has mentioned, different type of geometries, thicknesses, materials. Are the materials actually clean? Is there any dust? Is there any rust or oil or something on top of the welds? So there are quite a lot of things that take account into this achieving the perfect welding quality. And this is something that we are also constantly learning here, because welding is an art, so to say.
Thank you. On the next one, so Mohit is asking, can we upload programs to any robot using visual components like ABB's Robot Studio and ROBOGUIDE? Can we directly upload programs to all these? Is it possible using VC?
So I think we already covered this a little bit. So yes, it is possible. So we can create the programs that we can then transfer to the real robot directly from the software.
Then next question is from Ville. Is it possible to combine a robot program with a process modeling flow, or use a robot program in a process node? For example, a conveyor in a PM flow supplies a frame. Robot works on it according to a program and places the finished product on a new conveyor back into the PM flow.
So unfortunately, this is currently not possible to combine fully with process modeling, and this has some limitations on the capabilities of what we need to have in OLP world to be able to export this program and configure this program together with real-life robots. So unfortunately, right now, this is not possible. You would need to separately create the program in the OLP to be able to set it up correctly so that the real robot can execute it.
Thank you. I have a hand raised from somebody already was asking before. I will bring again on screen. Is it a new question? So Vibe Hub is the screen name.
Hello again.
Yes.
So in this software, how can you use simulation to develop robots that can work alongside humans? There are some situations in real life, humans are alongside the robots. So is it possible in this software?
Yes, so we can simulate the safety zones around the robots. So we can create kind of like these areas where we can assign motions for virtual humans that we can see inside the software, and then we can assign those to be inside those safety zones. Unfortunately, currently it is not possible to directly define exact robot safety zones. So in FANUC, we, for example, talk about DCS, so digital configured safety, where we have kind of like the restrictions for the robot where we can reduce the speeds entering in a specific safety zone. But we can simulate the safety zones and the cooperation with humans inside VC.
Thank you.
Thank you very much. And then one more question from the chat from Dalalio. To best simulate the robotic cell, can I interface VC with scripts or similar tools to manage tool change, workpiece change, packages, and pellets in the case of PAL and DPAL?
Yes, so if you talk about simulation, you are able to use scripts. So you are able to create Python scripts, for example, that you can use to simulate and manage these type of tool change and change applications. So the API for Python is fully out there that you can take a look. We have a quite good documentation of the API in our help manuals. So you can take a look on those and the existing scripts that you can find from the components from the eCatalog to find out yourself and make your own simulation as you want. So that is possible.
Thank you. So we are approaching 1 hour mark, but we do have a little bit time left and no questions. Severi, would you like to show us something?
Yeah, so I will quickly also show something else where some of you might be interested also. So now we have been taking a look about these welding applications, and Vanessa showed all of us how easy and fast it is to create a simple welding layout yourself. But I also wanted to highlight a little bit about all the different configurations that are already existing over there. So when we have the software open and we go to the models by type folder in our eCatalog, we can open up the layouts OLP section where we have 14 different layouts that we can take a look. How does the OLP work in all of those cases? So we have a few of different arc welding configurations. So we have simple configurations where we have just a robot and 1 2-axis workpiece positioner. We have also more complicated ones with multiple robots, like, for example, having 2 of the robots work together with other robot acting as a robot as a workpiece positioner. So we can do this so-called jigless welding. Then we have fully synchronized and handshake synchronized multi-robot programming layouts. So we can also see the synchronization, not just between 2 robots, but also between 2 robots and the workpiece positioner. So also these more complex cases are well represented over here inside our example layout. So you can just drag and drop the layout and press play to see the simulation. How does it work and how is the programming done in those type of scenarios? What I also now wanted to highlight is a little bit of the different processes that we also support. So as I also mentioned previously, the different processes inside Visual Components are now already active. So you can basically use the same license to program different applications like painting processes. In this case, we have a conveyor painting layout with 2 robots that are painting kind of like a moving object there in front of the robots. And here we can inspect the simulation of the paint. So we can apply the thickness evaluation option to evaluate also thickness patterns that we can get on top of moving components inside this layout. So what will happen is that we can get information about the real accumulation of the paint, but we can calibrate according to our calibration measurements there on site to have accurate description on how much paint do we actually accumulate on top of the workpiece when we execute the painting motions. So we can use different type of inspect tools to inspect how much paint do we actually accumulate on top of this workpiece, and do we achieve the desired thickness of, for example, in this case, 50 microns that we can see in the image there on the right. And you can see with the heat map, where do we have a possible overspray, where do we have underspray, and we can then modify our programs accordingly by adjusting the speeds, flow rates, or the paint viscosity parameters. Then I also wanted to highlight a couple other layouts. So I'm going to clear this one and show also something that has been seen in the industry as a growing thing. This is so-called jigless assembly. So we are now combining handling operations together with welding operations and assembly operations. So we are creating kind of like a pick and place routine where we also use the robot to place and assemble the product in front of the weld robot. So we can then see how does our total assembly end up from this pallet here to the welder so that we can actually weld and assemble complete workpieces piece by piece in the correct order and accurately. So in this case, we have a gripper that we are controlling. We are able to go to the program tab and see the motions and programs for our handling robot. And then we can see the re-grabbing so that we can accurately position the parts using this gravitational table. And in the end, we're having an accurate, exact, and efficient assemble program for our workpieces. And the last one that I want to highlight is about surface processes. So we have a little bit simplified surface sanding case with this type of, you can call this like a bonnet or a hood of a car or something similar. And in this case, we have applied the robot with a force feedback sensor. And in this force feedback sensor, we can also run the simulation and see how much time does our abrasive spend on top of the hood of the car. And then we can analyze how much material are we removing in all instances on top from the surface. And then we can have accurate estimations also, how much force do we need to apply it with the force feedback control of the tool that we have mounted on the robot. So with these tools, you are able to inspect, visualize, and create efficient robot programs that are also accurate there on the real life. So when you get your trial licenses, take a look at the layouts OLP section inside the software, play around with the layouts. Of course, these are generalized, so they use our own Visual Components robots, but you are still able to use, for example, the post processors for your specific brand to take a look on how does the program look like. So all of these different post processor brands that you can see over here is the ones that we support creating the code out and putting them to the actual robots. So that was everything that I wanted to show you here in the end. So go and take a look at the software with your test licenses and give us feedback. How does it look?
Yes, thank you very much, Severi. I think we have two small questions still in the chat before we go to the licensing and the poll from the same person, from Mohit. So let's take those two, but no more questions today. So MultiMove possible in Visual Components is the first question, and the second, in Visual Components, how many robots programming can be controlled and how many robots can be simulated?
So MultiMove is possible in Visual Components. So we can post-process the MultiMove commands for ABB. And there is practically no limit in Visual Components on how many robots can we simulate in the same time. So we don't have any limitation on our side. But what is a limitation is, of course, in reality. So depending on the robot brand, there can be limitations of how many robots can you actually synchronize with each other, depending on how you are synchronizing those. And I still want to quickly show one more thing, because I think this is a little bit related to this one. So here in the layouts OLP section, we had one of the multi-robot layouts, and we have a note also here in the layout. So we have examples on the brand-specific multi-robot terminology that we also support here in Visual Components, and those include FANUC multi-arm functionality, which basically means coordinated motion between two or more robots. We have KUKA robotin, where we have two different types of synchronizations, program and motion synchronization. Then we have Yaskawa with twin coordinated motion and coordinated motion, and also ABB MultiMove with three different synchronization steps. So either fully coordinated synchronized motions, semi-coordinated movements, or independent movements. So all of those are supported in Visual Components.